So when we have a SNP, well, I guess let's back up. When we get a gene, we get one copy from our mom, we get one copy from our dad. So if you get the same copy from each of them, then you're going to be homozygous. If you get one that's one copy and one that's a different copy, you're heterozygous. So the same with these, we could have a 6-7TT heterozygous or homozygous variant. If you have that homozygous, meaning you get two dirty copies, again, we'll use Dr. Ben Lynch's terms, that could decrease that MTHFR function by 70 to 75%, so that enzyme function. If you're heterozygous, meaning you got one clean copy, one bad copy, then that could decrease it like 33, 35%. If you have that 1298cc, again, homozygous, so two dirty copies, it can decrease things around like 40%, 39 or so. And then if you got a heterozygous, so one clean, one dirty, it's around 17%. Now you can have a compound heterozygous. What that means is that at one of those spots, you've got one clean, one dirty. At the other spot, you've got one clean, one dirty. I see different numbers on this, so I think it depends on which source you get. And so with the other decreased efficiencies that I've quoted, you can probably find some different numbers that'll change that just based on where you're looking. So anyway, if you've got that compound heterozygous, basically it looks like that function could get you similar to that homozygous 6-7TT. So it can have a pretty significant impact. Again, can. Just because you have these does not mean that's actually what it's doing. So again, if you quote unquote have MTHFR, it doesn't necessarily mean that you've got this, 0.75% reduction in activity of that enzyme. And again, we shouldn't say I have MTHFR because we all have MTHFR. What we're trying to say is, do we have one of those SNPs or not? So again, just trying to be critical and clarifying with words.